Okay, so context to what we're doing now. We want to implement something to now like remove a card from a deck, and you just offline told me that your idea is to remove, like have. So let's say we have a card, or they have a method called draw, right? And that just takes in nothing. It will return back as some card, some card. So you're saying that when we draw out a card from the deck, that removes the card from the deck, from that list, from the collection. So basically, take out a card from a collection. So then collection is permanently altered, right?
Yeah.
And then we return back the result. So it's kind of like a queue.
Yeah.
Yeah. Okay. So then, what were you saying? Like then now, like the user gets back a card as a result. Yeah. So is it their responsibility to do what they need to do with it? Like let's say they want it back into the card stack. Since it's removed permanently, they had to add it back in.
Yeah.
Okay. And then what? You said something about like an archive stack. That would just be a different stack then.
Yeah.
You would then the main would just create two, right? Two stacks. One is the regular card stack, and the other one will be an archive card stack.
Yeah. So I want to take out the top of the card, do like flashcard and test myself, and then once I'm done, I could put it back into the stack, or I could put it into the archive stack if the card is too easy for me, so I could reuse later.
Yeah. So why don't we just do something like that real quick, right? So in this case, okay. So draw. We need to take out the top card because that makes sense. When you're doing like flashcards, you're kind of flipping through the deck, right?
Yeah.
So then we can just say result equals, what is it, self dot collection, and I think it's pop.
Yeah.
Pop 0, right? And then we can just return the result in this case. What's interesting is that we do need to do some error checking, right? We can't just like pop an empty collection where there are no cards. So usually like this is the perfect time. Like these methods in classes give you an opportunity to do what you want to do, right? Like validation is a good example. In this case, when you draw, you don't want to draw from an empty deck. So we should have a check to check the length of the collection, right? And if it's empty, we should at least return something, return none, or let's try to raise an exception.
Okay.
Because you shouldn't try, like you know the deck is empty, and why are you trying to draw from an empty deck? That's bad. So we should just error out. We should just kill the program, right? So we can do something like if len self collection is 0. Okay. Well, we can just, I think it's raise.
Yeah.
Raise invalid. I don't know something.
Like type error.
Let's do value.
Okay.
All right, value error, and then let's give a message. You can't draw from an empty deck stack.
Okay.
Let's call it deck. Let's call it deck. Okay. So that's the error, and then we'll return back a result. Okay.
Okay.
So what you're saying here now is, if we were to go back to main, we should have, 3 cards, right? And we have, so we basically load up the contents to get 3 cards into our collection here. Is that right?
Yeah.
Okay. So if, let's say, after this line, we were to say something like card stack dot draw, we would get a card, right? So we could say top of card or top of deck. Okay.
Yep.
Okay. So then let's print out what the top of the deck is. We can just do that right now.
Okay.
So I expect that to be like OSI or 7 or something like that, right? So if we were to do main.py, yeah, we get this. This is kind of noisy now. Let's just get rid of that. Okay. right there, right?
Yeah.
Networking OSI layer 7. So that's the top.
Uh-huh.
Okay, so I wonder now, okay, if we were to do that code where we iterate through again,
Yeah.
do we have our card? Let's see.
Okay,
Okay.
since it was already
Yeah.
popped out.
Yeah, so for card, and this is, we should save it into a variable, but whatever. Let's just, get the collection like this for the sake of, So print card to string, okay? So we should only have, like, if we were to comment this out, we should only have 6 and 5 at this point, correct?
Yes.
Okay, so let's do that. Okay, 6 and 5.
Okay.
Yeah, so our drawing works now, okay? Our drawing for the card stack works now. Now you said something like, oh, we can put it into an archive stack or just put it back, right?
Yeah.
Well, let's play with the scenario and actually putting it back,
Okay.
okay? So at this point, we can say print putting the card back, okay? So then we can just do card stack dot add top of deck.
Okay.
Right, so you're just adding the card back. But then when you add the card back, it's going to add to the end, right? And that's exactly what you want, right? Because
Yeah.
as you're doing that, right?
Uh-huh.
You're doing that flip where you're kind of rotating between cards. So that makes sense. So why don't we check? Oops. Why don't we check and print it out again? So now the order should be different. The order should be 6, 5, 7,
Uh-huh.
right? So let's do that. 6, 5, 7, right there.
Yeah.
So that's a scenario where like you're adding, like you're kind of just doing that normal motion of like top of the card. Okay, say the card and put it back.
Okay.
Right. That's pretty much that motion.
Yeah.
So you can even do it like this too. Like let's pretend, right? Top of deck, dot display. Okay, and then top of deck dot flip, and top of deck dot display. Okay, so let's do that. So, oh, I didn't print any of these, so let's just do that. Okay, again, let's try one more time. Okay, so looking at this, so you pulled out the card, you see it's OSI layer 7, you flip it
Uh-huh.
because you said stuff and you're just checking, and then at this point your deck is only 2 cards. So you have 1 card in your hand, you have the other 2 cards in the other hand, then you put it back.
Yep.
And then you got 6, 5, 7. So that's like, it's simulating that motion that you do, right?
Yep.
Okay, so we can get rid of that. Okay, now you said something about like an archive stack, okay? So if you really think about it, this is where like why having that card stack class becomes very useful. Because you have one instance here where it's like your main stack, but to create an archive stack, what do you think you need to do?
Make another card
Stack
stack.
instance.
Yeah.
Right.
Another card stack instance.
So we can just initialize archive stack. And it's just another one right here. Whether or not you want to create it before or after, it doesn't matter. Okay? So once you're done with everything here, we don't want to put the card back, right? We can do something like archive stack dot add top of deck.
Okay.
Right? So now we're going to print archive. Okay? So archive stack is what we're printing now. Then we can print card toString. So that should only have 1 card in this case. So we, after we've drawn from the regular card stack, we're going to print what's in the card stack. Then we're going to add the card that we drew into the archive stack, and then we're going to print what's in the archive stack.
Okay.
So there should only be 1 card in this case. So that's true right there.
Yeah.
Okay? So that's really that is a good pattern. Like you just leave it to the person that is programming this to actually be responsible for this result. You can't try to Okay, so here's advice, like in object-oriented programming. When you define a class, right, when we define, so define means to give implementation, okay? So when you like implement that class and you design a class, make sure that your class does like that one thing and one thing very well, like in terms of like it lives to just have cards,
Yeah.
to add cards and to just give you cards out.
Okay.
You know, like you have to limit it to that point so that then what you can do is that okay, if you find that you need to like put it like you know have these other features where you want to put things in or out, well think about creating another class that can take care of that, and maybe have it be composed of these other classes that you have.
Okay.
You know what I mean? Like composition. You know, combine 2 or 3 have them be instances. Like the instance of a card stack could be an instance variable of another class.
Yeah.
Right? So you can have like a group of card stacks, and that can hold maybe 3 card stacks.
Okay.
Right?
Yeah.
Something like that. But that we have no purpose for that right now.
Okay.
Like, I don't think that's within scope. Okay, so now you've extended the card stack to have not only an add and a draw. Okay?
I do have another
Okay, yeah. What's the other feature that you were thinking?
shuffling.
Shuffle.
Like I want to randomize certain cards and then shuffle it.
Okay. Yeah. So shuffle. Let's think about the pseudocode and then let's think about Python later because my Python is not that good to write that code right away. So let's pseudocode this. So let's do def shuffle, and that doesn't return anything, right? It just like shuffles an internal collection.
Yeah.
Does it? Okay. So what's the pseudocode here? It's just what do we do? Just move the cards around?
Yeah.
Like how do we do that?
We move the cards around in the stack. So I was thinking about using randomize.
So for like a random number?
Yeah, for random. Yeah.
Okay.
Number.
So basically find a random number between 0 and the last index of the collection. So that'll be len minus 1, right?
Yeah.
Because it's 0-based index. Then what we want to do is we want to get that card at that random index, store that as a temp variable. Right, we need that because we don't want to overwrite that card that was there, right?
Yeah.
What do we do? Should we also first get a candidate card?
Yeah.
Like we want to take one card, find the index where we want to kind of put it in, but before that we have to take that previous card at that index, put in a new card, and swap it with.
Okay.
You're doing like random swaps pretty much.
Yeah.
Right?
Yeah.
We're doing random swaps. So what you want to do is get a card at a random index here. So you need 2 random index, right? So let's do this. Compute the random index between 0 and last index of the collection, then minus 1. Okay? This is the candidate index. Or let's just say card A. This is a swapping problem, a randomized swapping problem, right?
Yeah.
Call that card A.
Okay.
Okay? So get card A at that index.
Okay.
Okay? Now, again, let's do it again. Okay? Compute the random index between 0 and the last index of the collection. Let minus 1. Call that card B.
Okay.
Right? Okay? Swap A and card A and B at that index. At those indexes.
Yeah.
And you know the whole swap code is like T equals blah. You know, blah equals like that,
Yeah.
right? So, okay, so how do we actually compute? So how long do we want to do this? Do we want to do this till the end of the array?
I was thinking about maybe like a few times.
A few times.
Like
So
3 times.
so we want to go through the entire array and then go through it again like that.
Yeah.
Okay, so we have to iterate through the array 3 times, right? So already we know, okay, from I in range from 0 to 3,
Okay.
right? We want to iterate down on the array range 0 to the length of self.collection. Is that what you're saying?
Yeah.
Okay. So now we have to compute first index, right?
Uh-huh.
So we call it card A. Card A index is going to be what random index? So is it just random like this? Random dot what? So do we need to declare seed first? Random dot. I have no idea how to use this. Should we import random?
I think so.
Import random. Okay, random dot seed. I'm guessing this can be a time or it can be whatever. No argument, if none or no argument from the current time around. Okay, so it'll use the current time by default. Okay, so no argument will use the current OS time. That generates a seed. So we need to get random index dot rand int from what to what? From, is it inclusive? Yes, it's inclusive for both, right? So we want to go from 0 to length of self collection. That's how we're, I mean, that's how we're computing the index, right?
Yeah.
We want to get some random index from the 0 to whatever, right? And then we want to get card, well, let's say card A is going to be what? Self dot collection at card A IDX. Okay? And then we're going to do card B IDX. It's going to be random.randint 0 len self dot collection -1. Right?
Yeah.
And you get card A or card B at that index. And we're just going to swap.
Okay.
Right? Card B index. Okay? Then we're going to do T equals, was it card A?
Uh-huh.
And then card A is going to be, oopsie, self, well, actually, we already have the references. We don't even need to swap that way. We just do this. Right?
Yeah.
Just do that. And then, right?
Good point.
Yeah.
Uh-huh.
So we just do what you said like 3 times. And then we should have it shuffled at that point. I'm going to quickly do that. I'm going to quickly demo that and just see what happens. So, okay, let's get rid of all this. Get rid of all this noise. Okay? Now we're going to do card stack, shuffle. Okay? And then we're going to print it out. Did we do anything? Oh, it does. It does.
Oh, yeah.
Yeah, it does shuffle. Look at that.
Sometimes it
7, 5,
would
6, 6,
overwrite
7. Yeah.
it.
No. I mean, it makes sense.
Oh,
Right?
yeah.
We only got 3 elements, right?
Oh yeah, that's true.
Yeah,
Okay.
it does work. See, so it's randomized. So
Cool.
good job. Yeah, so that's another method that we have. All right, cool. That's enough time for today. So
Thanks.